All right, well, thanks everyone. We are, I think, the last session of the day, or the second to last session of the day, I believe. So I think we've got a super exciting panel for you guys with a super interesting topic and, much more importantly, great speakers from a variety of distinguished institutions. I think everybody's heard probably 10, 15, maybe even 500 panels on Hadoop and why Hadoop itself is transformational. So we figured we'd do the next thing, which is go beyond Hadoop. And to that extent, we've got Joe Hellerstein from Trifacta. We've got Justin, and I got Erickson from Cloudera. We've got MC Srivas from MapR, and we've also got Kwek from Google. A distinguished panel of folks who understand both the current state of tooling, but also and database management systems, but also what could come next. And the goal with this panel is to explore the future, what the trends are, and to highlight what differences and what similarities that this group of people might see within the future. So with that, what I want to do is just ask everybody on the panel to give maybe a 1 to 2 minute introduction of who they are and their companies. And then from there, we can go from right into the panel and talk about the future. Joe, I'll start with you.
Hi, I'm Joe. Oh, there's a switch. There's a switch. Hello. Hey.
There we go.
Hi back there. I'm Joe Hellerstein. I've been on the faculty at UC Berkeley in computer science for much longer than I would guess, since 1995. About a year ago, I started a company called Trifacta with a couple of colleagues, Jeff Hare, who's on the faculty at Stanford in computer science, and our graduate student, Sean Kandel. And Trifacta is a company that's trying to help data analysts be more productive.
Hello, everyone. I'm Justin Erickson. I'm a product manager at Cloudera. I specifically work on the Hadoop storage platform, so that's HDFS, HBase, our query technologies of Hive and Impala, and also our performance engineering team. So for those of you who have not heard of Cloudera, I'm hoping that there's very few of you that have not heard of Cloudera at this point. We are the first Hadoop distribution out there in the market, and also the most commonly deployed Hadoop distro. And obviously around that we have management tools and our services offering. That's where our company maintains its leadership.
Hi everyone. My name is MC Srivas. I'm the CTO and co-founder of MapR Technologies. We produce a Hadoop distribution too. And our claim to fame is we're probably the best Hadoop distribution. So, of course. And a lot of our innovations around making what's like a read-only system into a read-write system. So we have pretty much a data platform that can handle data in various different forms and not just Hadoop. It's way more than Hadoop. And that's really the value we bring to our customers.
Hi everyone, my name is Kwek. I'm at Google. I've been there for about 4.5 years. I have a background in enterprise software. And I'm responsible at Google for the product strategy behind the externalization of many proprietary Google technologies. So principally, I'm responsible for a product called BigQuery, which you may have heard of, but it allows you to do interactive SQL-based analysis on terabyte-sized data sets, and a host of other products that we have lined up behind that. Previously, like I said, enterprise software, I've actually spent a little bit of time at SAP back in the day at corporate research. If you didn't know, the soft serve in the cafeteria over there, very good.
Very cool. So, Juke, why don't I start with you? So, what's beyond Hadoop? What's the next big thing? What are customers caring about? What are the big problems that need to be solved? What are you guys seeing at Google?
Sure. Well, we're seeing quite a few things at Google. I think before we get into beyond Hadoop, I think it's worth spending just a minute, acknowledging the the importance of Hadoop, and certainly, I mean, I think MC and Justin are going to tell us more about that. But I think a good way there are look, there are so many technologies that are flying all over the place. They're powerful. They're useful. How do we incorporate them, right? I think it's important to acknowledge Hadoop as a foundational technology, right? And where there's complexity, I always like to think in terms of analogies. I always think of Hadoop as sort of like the first car, the Model T. Before the Model T, you could build a car, but you had to be a car engineer, right? And what we have started to see first with the open source distributions, and now you're starting to see maturity, right? In the distributions here is more than car engineers. It's equivalent of more than car engineers able to drive a car, right? And so, having set that foundation for what Hadoop is to this notion of data analytics and storage and processing, it then becomes interesting to think about, well, what can you build on top of that foundation? And again, if you think back to the Model T, what did the Model T lead us to, right? It led to trucks and sports cars and minivans, oh dear, right? But it's really an enabling foundation, is the way I see it. And the really interesting things that are coming are not just at the technology level, but think about the kinds of new business processes and business models that the car enabled. And so when you kind of really step back from it and you look at this in the context of history, right, I think it's fair to say that we are at that very foundational stage right now, and it's starting to get really interesting and exciting because most of the innovation is ahead of us.
Srivas, do you have a view?
I think totally agree with what Kwek was saying. Essentially, Hadoop is, I'm also from Google. That's where I used to work before I started MapR, and Hadoop is really it came out of Google really. If I would go back and give the credit where it's due, they invented this technique of Mapreduce and with Bigtable and GFS and so on, and in Google, it's the foundation for everything, and I can see that happening. It being the foundation for everything in the enterprise, across any vertical. What Hadoop really brings is the cost of storing and managing data is so low compared to any other technology that's there today. So we're talking about 2 orders of magnitude cheaper than, let's say, an Oracle or a Teradata. 1 order of magnitude cheaper than, let's say, any kind of NAS like a NetApp or a EMC. And so when the prices are so low, it is very disruptive, naturally disruptive. And that's going, and it's a matter of time about when it happens, but it will happen. And so once you have that, so now what can you do with it? And that's really the next question here. If I look at what Hadoop was really good at when it first came out, was about analysis. And now what we're seeing is we're seeing across the board use cases in many different industries where it's getting more real time, it's more interactive, it's more immediate in the sense that, so it's becoming a data platform where you can, a way to ingest data and dump it there because it's so cheap, and dump it in various forms, whether it's through NFS or through Storm or through any kind of real-time or non-real-time way. And then once you have it there, you need to, of course, save and retain it. So that's where it kind of, you need the enterprise class features like snapshots, mirroring, DR, and all of that, where it has to be retained safely. And then the next step after that is to be able to now, okay, I have all this data, what do I do with it? So I need a way to analyze it. Well, that's Hadoop or MapReduce. I need a way to find where things are quickly. So that's where all the SQL solutions like BigQuery or Impala or Apache Drill or all of these things are doing. Or I need to be able to search it, right? I mean, this is what Google became famous for, which is search, which is full text search and contextual full text search. So there's Lucene, Solar, Lucene-based solutions like Elasticsearch and Solar that are becoming very popular. So now I can find things that I put there. What else can I do with it? Well, after that, I need to be able to notify outside Hadoop what's going on. That is, okay, I found something interesting. Now I got to tell somebody else, hey, there's this thing interesting. Send an alert, send to this thing, send something, some notification. And so I think all of this comes as a one big data platform underneath Hadoop. Whether it's NoSQL or whether it's SQL, I mean, that's kind of secondary almost to the point that this is one giant dumping ground for all your data in one place. You won't have data silos anymore. And I think that's where Hadoop is really going to.
Okay, Justin?
Yes, I'd agree with a lot of what the previous speakers say. I often go and say, when you look at Hadoop and why it's been able to achieve what it's been able to achieve so far, and why we're moving towards this unified data platform, I really look and say it comes down to 3 big things that Hadoop has been just an order of magnitude or more better than alternative options. One is obviously the scale. So the ability to be able to handle big data where I can handle 10 nodes, I can go into the many thousands of nodes, and I can just continue to throw machines at the problem and not get bottlenecked on either the processing side or network side and other factors. And Mapreduce, as a first part of the Hadoop framework, has been built around that premise. The cost is obviously another big thing. If I'm looking at storing large amounts of data, I'm trying to say that there's a good amount of data, and I'm trying to find these needles of insight within the haystacks. And so having a price point where I can collect data just in case there might be something interesting that my data scientists or analysts can look at later is a key thing. And then the flexibility of the platform. And a lot of that comes to the ability to store multiple different types of data. I can do things like your fully structured data where I know exactly what the data looks like up front. That can obviously go within Hadoop. But I can also do things like completely unstructured data sets like videos and images, which I may not have do not have a way of expressing in a tabular form. But there's actually this piece in the middle of data sets that are coming in that I may not want to spend the time at the time I'm collecting that data to know exactly what that data looks like and form it into a structured process that I'm going to then go and analyze knowing how that looks. I kind of want to be able to say, hey, I can just throw the data in. If I want to go and do something with that, at the time that I'm going to do the analysis on that data set, I can then take the cost of going and storing that. And it's kind of like if I told you that you can take notes and we have to upfront define, here's the structure of a sentence. And every one of the sentences that you take down from this panel needs to be written in that way. You're going to write a lot less than if you just write things free form. I think that becomes a key portion of why Hadoop has been able to achieve what it's been able to achieve thus far. And going forward, as we look at a unified data platform, we're starting to see the same thing with frameworks like the Impala project that's out there now, where the data comes into Hadoop, and I have the processing now come towards the data. So I have one giant pool of data, and I can run MapReduce on top of it and maybe do my ETL processing or machine learning processes. I can now also take the exact same data sets without having to go and bring them into another silo, load them into another format or anything else, run SQL processing on that. And I think that story will only continue, where the gravity around the data is going to be able to pull more processing onto it, whereas before, you have these disparate silos where I'm moving data between systems for particular needs. And I think that's really the story of where Hadoop is going forward.
Okay. So Joe, past panelists said, Hadoop is, not dead. Long live Hadoop. What are you seeing as sort of the problems with regards to, or are there any problems with regards to Hadoop or going beyond Hadoop?
Yeah, so I've been watching this space for a long time, coming from a background in traditional databases as an academic, where I think about this as a set of technological options. You can build a lot of data backends, and when the Google MapReduce paper came out, my reaction was, well, that's a nice, simple, very scalable solution. If you really needed to scale up to tens, hundreds of thousands of machines, that's a point in the design space that would scale really nicely there, and that's nice work. As the conversation has rolled forward and Hadoop has become a distro that people identify, I think the most interesting thing about it, I like to say, the most interesting thing about Hadoop is that everybody's interested in Hadoop. All right? The artifact is simple, and there's an elegance to that simplicity. But what we're seeing with things like Impala and other things is the question, what is Hadoop, is getting really actually quite complicated. It used to be Hadoop is a MapReduce programming framework over a file system with an engine that runs those MapReduce programs. And we all sort of understood what that was. And then people said, well, but I'd really like to access that through a SQL syntax. And so Hive was built and Pig was built, and these were thin veneers that sat on top. As Impala comes along and says, if you really want to do SQL, it'd be more efficient to just move that MapReduce query processing engine aside and put another query processing engine on top. You start to get to a point where like, okay, and then MapR comes along and says, the file system's really actually not that powerful. We have a better file system. You could slide under the MapReduce engine. You say, okay. And then you say, well, what if you took the Impala query engine over the MapR storage engine? Is that Hadoop anymore? And the answer is, I don't know, who cares, right? So for me, this is a technology space, and the fascinating things about it are, first of all, that it's rallied a community of creative companies and engineers and actually advanced aggressive users around a new way to think about how you do data processing at scale and what you do it for. And then the other thing that's really interesting is that it's changed, I think, the enterprise data processing industry, the enterprise database industry, in a way that was inconceivable 5 to 10 years ago. The idea that you could take an open source system and roll it in and replace Oracle. I worked on Postgres as a graduate student. I mean, we had in our docs comments to the effect of, I wouldn't put my data in Postgres, you know, in 1990, because like databases were the place where like, you know, oh my God, that has to be, you know, bulletproof industrial software. The idea that all of us would be gathered around talking about this evolving, changing, fluid, you know, immature but really exciting and growing tech space for data management is phenomenal. So for me, the conversation about what's beyond Hadoop is more Hadoop, whatever the hell that might be, but it's going to be a lot of fun.
So then what are the big problems that need to be solved? Maybe we can think about it from a problem-based perspective instead. So what are the big problems that can be solved? So go ahead, Joe.
Yeah, I'm happy to jump in on this one because this is actually where my passion is. I've worked on engines a lot, and I think they're really exciting, and I kind of have gotten to the point where I feel like it's a big design space. You can build a lot of things. What's really hard right now, with both SQL and Hadoop, but especially Hadoop, is getting people to get utility out of it. So you can stand up a big Hadoop cluster, you can stand up a medium-sized Hadoop cluster with very little effort and little cost. You can land data, which is one of the wonderful things about it. You don't need a schema, you just land your data, you get your data reservoir, your lake, and then what? And a lot of organizations right now in their big data explorations are at the and then what stage. And you know, the answer you'd like to get is, and then you use your business intelligence tools, your machine learning tools, and you get insight out of the data. But there's a big step in between the landing of the data and having it ready to load into your Viz tool or your SAS or your R. And that's just a whole bunch of icky work that people do. And when we go out and we interview analysts in this space, they say they spend 60 to 90% of their time, depends who you ask, doing all that data prep, all that sort of grungy, messy data wrangling. And so I think that problem's got to be solved. That's what my company's out doing, Trifacta, because we just heard over and over that this is where the bottleneck is right now.
Okay. And Justin, what do you guys hear from customers?
Sure. So I think that there's a whole bunch of different angles to go into Hadoop. Obviously, there's one that Hadoop itself is sort of growing up and maturing and going into is already being deployed in sort of mission critical capacities within enterprises. And that obviously requires additional kind of requirements around the availability, the security around that framework. And we're seeing those kinds of things are clearly already, a lot of them are being addressed, and they're improving pretty dramatically there as well. But I also see that sort of the stage of as people are trying out Hadoop and its technologies goes through about 3 phases, I'd say. First phase is I have a problem today that I'm not able to achieve, and I really need to go and find a new technology for, and often that's what starts with Hadoop. And the most common one and the sort of the easiest one to grok there is my ETL windows, I'm no longer able to process the amount of data that I need within my ETL window, and I need something more scalable to go and solve that. And that really is taking Hadoop and solving a problem that existed before and just using a new framework that can do it in a much more scalable and robust way than what was achieved before. Once people get to do that, then they start realizing the power of this platform is so much more than just replacing existing sets of technologies. And I actually see one of the biggest challenges is, as people get into the space and realize what it can go and do, is that shift in mindset for some becomes kind of tough. So the training and learning around how to think about the problem differently and how to think about new problems that weren't things that they were grappling about with before. And as part of that, the next phase is sort of the tooling and infrastructure that, okay, now that I understand what I need to go and do, I have the right training around that, do we want to have every enterprise go out there and build their way of going and solving a set of problems? And that's where you get the ISV ecosystem. While very robust today, what we're seeing so far is a lot of the existing tool sets now say I have a big data story. And there's going to be a pivot from the existing tools to now say, hey, let me not just solve the same problems I was before on the traditional database world. Let me take advantage of this new platform and do new things, and see great new companies come in like what Trifacta is trying to do and say, hey, this is a brand new world. When I think about unstructured or semi-structured data coming in, how do I get it ready to go and analyze that? When I think about that end-to-end problem of an event happens somewhere in the world, how do I make that available for the analysts and data scientists to go look at? That actually is a new problem space, and it'll be very interesting to see as this whole thing grows up of the technologies itself, more processing frameworks from a core technology standpoint. The enterprise is starting to think about the new problems and what they can do with data that may not have been occurred to them before and may not have been possibilities before. And then the ecosystem around it, both from the platform and the tools on top that make that possible without every company going and taking a Google-sized investment to make that a reality.
Okay. GK? I'll skip over Srivas and come back.
Aw. So this is a subject, yeah, that's near and dear to my heart, right? And I think it was kind of necessary to kind of set a baseline by talking about the technology. But to me, where it truly gets interesting is when the rubber really hits the road. And I feel very fortunate that in my position, I've been able to do that working closely with a number of customers, both in the ISV startup space as well as in enterprise. So I think there's two things to kind of touch on briefly here, but to illustrate and sort of think about this question of beyond Hadoop. First, I think it's useful to look what's going on inside Google with regards to Mapreduce and Hadoop-like technologies. And then how is that, there are some parallels. It's really interesting to see some of these patterns emerging in enterprises today, right? So just very quickly, right, just to touch on Mapreduce at Google and the big data processing at Google. So Mapreduce is basically the framework that was the precursor to the Hadoop distribution, the first Hadoop distribution. That was invented at Google, and I think the white paper was published back in like 2004, I think, five. There we go. It was a while ago, right? And so, as you might imagine, Google has done a lot of innovation and invention on top of those frameworks since then. And so, if you look at Google today and sort of look at it in the abstract, Mapreduce is still used a lot at Google, right? It's the same style of batch processing, that distributed batch processing that Hadoop is based on. And the typical use case for that is, oh, look at that, Gmail produced 100 terabytes of logs. How are we going to process that, all right? That's kind of the classical use case for Mapreduce because you can very quickly array hundreds, if not thousands, of machine nodes to break down your big data problem into many smaller parallel processing problems, right? But that's just the start, right? So at Google, right, these days, not many engineers are actually writing Mapreduce code. And the reason for that is because we've continued to refine the model and build up different pipelining frameworks on top of it. And so today, your average developer at Google will work with technologies, internal technologies like Flume and so forth, that are really kind of a higher level abstraction, right? With Flume, as a developer, you work with abstract objects or tasks that the framework then translates into these batch jobs and manages them for you, right? So what we're seeing at Google is one thing is this maturing of the framework into higher level abstractions, right? It's not far to see how you would, not difficult to see how you would make the jump from these higher level abstractions into GUI interfaces and so forth. And in fact, some of that is actually happening where you have analysts looking at dashboards or writing SQL, and then what happens is, right, you go off and you go and run a MapReduce job in the background. But that's somebody who doesn't have a Hadoop or a MapReduce software engineering background being able to kick off these very, very large processes. That's powerful, right? And so with Google, you have that, the pipelining going on, but you also have an adjacent set of technologies, right? And I won't get into kind of the details of this, but suffice to say, they've grown up, sort of together with MapReduce, right? And really the idea here is, it's horses for courses. So if I have a large batch processing problem, I might use MapReduce or some of these pipelines for it. But if I have a fast querying problem, I might use a service like BigQuery. BigQuery is not Hadoop, right? It's based on a separate but related distributed technology. And so kind of take it back to what's going beyond Hadoop. I think a lesson from Google, and when I say Google, I think the same is also true at places like Facebook and LinkedIn and companies that are dealing with very, very large internet scale data sets. That really the focus now is on the productivity and the integration with business processes of these underlying technologies. And I think that if you're doing it right, like these companies are, in my opinion, that level of technology, right, actually drops into the background, becomes part of the business process, right? So that's what's happening in Google, and I'll try and speed this up now. What's happening in industry is very interesting, and I'll just kind of maybe talk about one case study. right? So it's a very large photo sharing website that we're working with. And we're looking to publish a case study on this, when the project is done. But they have the following problem, right? So they have millions of users, each visiting the site every day, hundreds of interactions, which translates into thousands and millions of click events, right? They use Omniture. There's people here, you work with Omniture? I'm seeing nodding heads. So Omniture data, it's basically the click-by-click interaction of every single customer with your web application, right? That is a web scale problem, right? The size of the logs that generates, right, is literally hundreds of gigabytes, if not terabytes a day. And they realize that there's a lot of value in that data, right? One of the first questions that they're trying to answer, and they're trying to use some of our technologies or working with them to try to implement this, is, so I have 5 million target users. I have 300 email campaigns and many variations of the campaign against, right, daily billions of clicks on the website. So this becomes a big puzzle for them, and they're saying,
Keep going.
So they're saying, how do we know which campaigns were successful at driving which cohorts of users into the new features that we're trying to monetize, right? And you wanted to say something there?
No, I think I was just going to finish up on that thought and then sort of open it to the audience with questions.
So real quick, what they're doing is with a data analytics team, less with software engineers, right? And so one of the things that we're learning about is, where are those pain points? And there are many, right? I'll be honest. But that's where we are today, and I think that's where many businesses are going to start moving towards.
Okay. So I wanted to open up to the audience for any questions. Any hands? Okay.
We know you all have hands.
Yeah, no hands. All right. Let's front row first.
So thanks for the detailed explanation of some of the use cases, that are kind of planned to use. Earlier in the day, we had a pretty decent talk about real-time analysis of the data. For example, you have Impala, Drill, other technologies, right? So how do you foresee that panning out? Like people talk about data scientists, lack of data science. People of data science, that being one problem. The unresponsive or kind of slow responsiveness of the underlying framework being another problem. Right, so what do you see from a technology perspective? How do multiple tools or frameworks being stacked? And one other problem people talked in the past was kind of vertical, vertical solutions. There's not a general purpose solution that could solve all business problems, irrespective of the industry. Can you guys do you have any comments on along those three lines?
Why don't you take that one? Srivas, why don't you take that one?
So, very good question. I think, why does Hadoop win? Let me come back to that and then you'll understand why, right? Why does Hadoop win compared to other big data solutions? Because it's a family of things, it's not one thing, right? So what's interesting about Hadoop is Hadoop, certainly, but it's because it provides a standard API. And so when you have a standard API or set of APIs, a lot of companies willing to write code to it, and a lot of companies innovating above and below the API, essentially, right? And whichever the API is. So what you've seen is lots of companies doing vertical solutions on that set of API, right? But they still need bigger building blocks, like BigQuery, for example, right? Or Apache Drill, or we're kind of following, do what Google does, it'll probably do it right? Because they've had this problem 5 years before everybody else. But I think on the other hand, right? I mean, somebody here said, hey, everybody gets Hadoop, then what, right? Well, most companies already know then what, right? And in fact, we have had a lot of successes with a lot of companies that already understand their vertical very well. And in fact, if you look at, for example, if I go to a bank and say, hey, I'm doing risk analysis on Hadoop, you won't find a vertical app for that, because guess what? That's their secret sauce. A bank on how it does risk analysis is damn well they're not going to share with anybody else. Right? If I go to a web search engine and figure out how they figure out how to surface the results, they're never going to share that with anybody else. Or if I go to a telco and say, okay, how are you going to figure out what your cell phone provider users are doing? They're not going to share that with anybody else. So the kind of science you're getting into here, the data science, is actually the secret sauce of how the company works. So you're not going to get a cookie cutter app that says, I'm going to tell you how your thing, for something that's mundane, right? Like web log clicks, or for example, take for example somebody like Mozilla, right? Firefox daily crashes 2 million times. I mean, sorry if Firefox does, but maybe, okay, whatever application, Firefox may not. But given the large usage of it, right? If I have 1 billion users, it's very likely that there'll be 1 million crashes a day, right? That's less than 0.1%. Well, now how do I know which crashes to look at? Well, Hadoop's great for that. That's an example of where I would use Hadoop. But the vertical of understanding, if I'm in the energy exploration business, how do I look at all the instruments and I do the various mapping of the ocean floor to figure out where to drill? Chevron is not going to share that with mobile, or there's not going to be any vertical app for that. So that's the problem you're going to face. You'll have some vertical stuff, things like machine learning, or things like techniques on machine learning, but a vertical that says, hey, I know how to evaluate credit card risk, you're not going to get that. So that's kind of, we're on the gray area between what is proprietary to a business versus what's generic.
Okay, thanks. Sorry, there's a question in the back first, right over there, in the middle. Right, yeah, you in the blue shirt.
Yeah, no mic?
There's a mic coming to you.
Oh, thanks. Thanks. So my question is, relative to Hadoop, the topic you have, how does text analytics fit over the next year? Is it separate? Is it start to integrate? I mean, in the past, it's always been structured versus unstructured data, but so much text is out there and so many things can be done with natural language processing and so on. So what's the big picture trend going on here?
I'm going to give this one to Joe. So,
Okay. The canonical examples for MapReduce at Google originally were, PageRank and text processing feature extraction, word count, right? Which is just a very basic feature extraction. But my understanding of the natural language processing that's going on in the field is that it hasn't changed substantially in the last year. What you do is you get text, you run feature extractors, which are things that count up various kinds of statistics about the text and possibly feed them into models. So you're looking at things like occurrences of things or occurrences of strings of things or even possibly sequential analyses of text, but sort of in fixed documents. This stuff is evolving quickly and it's very interesting, but I don't think you should expect it to be a feature of Hadoop anytime soon. This is sort of like these machine learning algorithms. Different shops will do it differently. There's certainly best practices that everybody knows about and we teach in school. And Hadoop's actually a fine platform for doing that stuff. I wouldn't expect something big to change in the coming 12 months. It was the window on your question that sort of surprised me. It's an evolution. And we're pretty high up on the stack by now. The last decade's been a lot of rapid growth, and also many more people know about how to do this than used to. So best practices are much better known, and the engineers who know how to do it have cross-pollinated a lot better. But it's not a quickly changing thing, I wouldn't say.
in the front row.
Hi, Arun Das. I'm with a business intelligence software startup here in stealth mode. My question is actually it's kind of in line of the theme of the topic you guys are covering, beyond Hadoop. Hadoop is awesome. It's doing a spectacular job along with a family of other products, great products. Now my question is actually, well, you know, right now, 20 years back when I used to work at CERN Geneva, we handled data bigger than what you are calling big data today. We used to handle data 10 gigabyte per second. We used to generate data at that rate, and we didn't have this kind of architecture. We didn't even have Oracle database back then. Well, we had Oracle database, but that was different. So my point is, but that was unprecedented amount of data back then, and industry used to handle 1 kilobyte, 1 megabyte, 10 megabyte data back then. So from there, we have come to a point where every day, now world produces 2.5 petabytes of data every day. Now, Hadoop, well, it's a technology, great technology, but again, it's a technology. And like every great technology, it should have a lifetime. Could you foresee what would be the optimum lifetime of Hadoop along with the along with its allied upcoming technologies, 10 years, 15 years, 20 years, because in 20 years, 2 petabyte to, who knows, it might be 200 exabytes per day. So technologically and architecture-wise, how long Hadoop would be relevant?
So when is Hadoop going to die, Justin?
It's kind of always hard to go and predict the future, and anybody who ever tries notoriously gets it horribly, horribly wrong.
But that's why you're on this panel.
yes.
So,
But what I'd say is, I mean, a lot of it comes down to how the systems are evolving. And one of the great things about Hadoop is it is not a technology, it's a collection of technologies. And you see evolutions of things that were solving certain classes of problems before and now finding a more optimal way to go and achieve similar sorts of results, or a new kind of problem processing paradigm side by side with the old solution. And you see that happen within Google's own infrastructure as they've iterated on their GFS, and now they have another iteration of GFS, and they had a Tenzing and now have a Dremel, and similar to the same corollaries that we're seeing out here. I think that you'll see there'll be continued innovation in different paces. I think what we'll see is going to be some of the trends is as we move from certain parts of the architecture becoming bottlenecks, and as like Flash becomes more and more cost performant, either the existing technologies will find ways of incorporating those in, or we'll find that there's a fundamental shift that we would want to go and replace portions of that technology. But the key piece in this is as each one of the pieces can evolve and you can replace pieces of it and have other parts of the system continue to move forward with it, that is able to hopefully keep the shelf life of this going for a long while coming.
okay.
I have one
Srivas,
quick thing to add.
you seem like you
Yeah, go ahead.
do very quickly, because we
Just one word, AS400.
I had a different perspective actually on this. What else would you use if not Hadoop, right? Until you find that, Hadoop is going to live. So and given the enormous, the cost and the way to process semi-structured data, you cannot do it any other way today, right? So until you figure that out, you're going to stay with Hadoop. So you have to find the alternate technology first. It doesn't exist yet. So when it happens, yeah, it'll die then. And if it's better, then.
excellent. So thank you to our panelists. A big round of applause.